The name connective tissue tells us that very often connective tissue has the function of connecting other types of tissue together. When we form organs that develop into organ systems, those organs are almost always going to have some connective tissue found within that organ. Connective tissue is by far the most abundant and widely distributed tissue type in the body. What makes it, in my opinion, a little bit easier to learn to identify all the different types of connective tissue is they are variable. They look very different from each other. Something that makes connective tissue different from epithelial tissue is that most connective tissue is vascular, contains blood vessels. The only true exception to that is cartilage, which does not contain any blood vessels. So as we look through our connective tissue, we want to think of a few major functions. Connective tissue helps bind organs together, as I already mentioned. It provides support, both physical and immune protection, sometimes movement, because our bones are made of connective tissue, storage, heat production, and transport. When we look at connective tissue, one of the things we can do to help distinguish the different tissues from one another is identifying the cell type within the tissue and also identifying the fiber type within the tissue. This slide lists the major cell types found in different connective tissues. In fibrous connective tissues, we find fibroblasts. Fibroblasts actually produce the fibers in the tissue. In some tissues, we will see macrophages and leukocytes. These are part of our immune system. We may see plasma cells, mast cells. In fat, we will see adipocytes. So you'll learn as we go through these different tissue types that we can call the generic connective tissue cell something a little bit different based upon the tissue type. We have three major fiber types. We have collagen. Collagen is tough and flexible all at the same time. I always like to say you can remember collagen as tough but flexible because women like to talk about how their collagen is getting old and then we end up with wrinkles as our collagen loses some of its toughness and flexibility. Reticular fibers are actually just very thin collagen fibers found in just a few specialized tissue types in the body. Elastic fibers are the thinner, more stretchy types of fibers. This picture shows you some tendons and ligaments, helping you see how underneath this epithelial tissue we start to see, if we remove the skin, we can start to see some of our connective tissues. In our connective tissues, we are not going to see cells all packed perfectly close together, touching one another. So you're going to have some other stuff in the tissue besides the cells. The extra stuff is what we call our ground substance. Ground substance contains many different types of sugars and proteins. So let's start looking at these different types of fibrous connective tissues. We categorize them as loose or dense. And just as the name implies, if it's a loose connective tissue, you're going to have a lot of ground substance with just very little fiber and cells. If it's a dense connective tissue, you're going to have more fibers, more cells, and less of that background ground substance. So here's our first type. It's called areolar tissue, sometimes just generically called loose connective tissue. Kind of use those names synonymously. So you can see here when we're looking at this picture, Get a color pen you can see well. When we're looking at this picture, you see what looks like lines. Those lines are actually your fibers. So in this one, we have some thicker, more straight lines. Those are collagen. And then the more squiggly thin ones, that's elastic fibers. The dark spots, those are the nuclei of your fibroblasts. You know they're fibroblasts because this is not a specialized type of connective tissue like cartilage or adipose tissue or something like that, so we call them fibroblasts. They are producing these fibers we see here. Areolar connective tissue is found underneath epithelial tissues. So if we think about our skin, the outside's epithelium, directly underneath is areolar connective tissue. This is reticular tissue. Notice the fiber types look different. These are reticular fibers. The dark, more circular spots we see, those are still the nuclei of fibroblasts. And then all the squigglies, those are your reticular fibers. We find reticular tissues in our immune system tissues, like in organs, like lymph nodes, spleen, thymus. Dense, regular connective tissue. So even if you have absolutely no idea what you're looking at, you can see how these tissues look more dense. The fibers are packed more closely together. This is considered regular because you see the nice regular pattern. All of those fibers run in a perfect order. It's harder to see, in my opinion, but you can see every now and then, see the little nucleus? That's your fibroblast again. We find dense, regular connective tissue in our tendons. Here's dense, irregular connective tissue. Kind of looks like a Picasso painting. See how the fibers are not perfectly in a line anymore. They're all mixed up together. So you still have fibroblasts, you still have collagen fibers, they're not just in a perfect line. We find dense, irregular connective tissue in the deepest layers of our skin. Adipose tissue. This is our fat. Adipose tissue is a very specialized connective tissue holding our triglycerides, which is how we store energy inside of our body. We do have white versus brown adipose tissue. As an adult, most of your adipose tissue is the white type, providing insulation and really just hanging on to excess energy. Our brown adipose tissue is found mainly when we're younger, and it's really just darker because it's got excess mitochondria, blood vessels. We use it more for heat generation when we're very young. Here's our picture of the white adipose tissue, which is the one you're responsible for identifying. These big empty white spaces, that is actually fat. That's your triglycerides. The nuclei are smushed over into the corner because the cell is full of fat. We call adipose tissue cells adipocytes, and you can see that term here, adipocyte. Next, let's look at our three different types of cartilage. Cartilage contains specialized cells. We have the chondroblast that actually produce the tissue from start. Then chondrocytes, these are our adult cartilage cells. Chondrocytes sit inside of little cloud-like structures called lacunae. So let's look at our three types. Again, remember, cartilage has no blood vessels. When you see cartilage, it should pop into your head that this looks like a tissue type that has eyeballs. The eyeballs you see are actually the lacunae housing the chondrocytes. Hyaline cartilage, this first type, has fibers, but you just can't see them. So it looks more like a clear background with those lacunae holding the chondrocytes. We find hyaline cartilage in our cartilage on the end surfaces of our long bones. That's called articular cartilage. Also within the cartilage found on our rib cage, and then in the trachea. Elastic cartilage, as you could probably predict, has a lot of elastic fibers. So you see these thin black streaks in this picture. Those are the elastic fibers, but you still see the eyeballs, the lacunae holding the chondrocytes. Elastic cartilage is much more flexible, so we find this type of cartilage forming the outside portion of our ear, and also something called the epiglottis. We'll learn that it helps to control the direction of food and movement as we swallow. The last cartilage type is fibrocartilage. Really thick bundles of collagen are our fiber types found here. So it's a little harder to see because typically we show you this a little bit further away, so it's not as magnified. But if you look, you should still see the little lacunae holding the chondrocytes. And so kind of a line of it here. I think this is probably a good one to look at. Okay. So you should still look for the eyeballs to know this is cartilage. Fibrocartilage has the function of resisting compression, and it's found in a couple of important places. It makes up the disc between our vertebrae, and it makes up what's called the pubic symphysis, which is the site where our two hip bones come together. Next connective tissue type is bone, or better known as osseous tissue. We're going to talk a lot more about bone when we get to our section on the bones. Right now, you should be able to recognize microscopically the different bones, spongy bone and compact bone. Let me show you the picture. This is compact bone. It's the easiest one to me to identify. It looks like tree trunks, like you've cut down a tree and you're looking at the concentric rings of the tree. So in the very center of the tree trunk, you have what's called this dark spot, the central canal. Then you have some other structures here, the lamella and the canaliculi. Those are all different channels that form this nice concentric rings that looks like a tree trunk. But one word I want you to recognize, look at this, lacunae. Remember how lacunae was the little space that held the cell? Same thing here. Inside of these lacunae, you're going to find osteocytes, because this is osseous tissue. You do have blood vessels running through your osseous tissue. So what's going to happen is you have the dark spot in the middle. That is the central canal. Then you'll have one layer of bony tissue. That's one lamella. Then another lamella. Then another lamella. Then another lamella. Then you'll have the little canaliculi connecting them together. This whole thing is called an osteon. But again, we're going to learn that in a lot more detail when we get into bones. But right now, you should be able to recognize this osseous tissue. One more connective tissue to learn, and that is blood. Blood is our fluid connective tissue that travels through our blood vessels. Inside of our blood, we have erythrocytes. Those are our red blood cells. Leukocytes are our white blood cells. And then platelets are cell fragments. So looking at the picture, you can see we just looks like we just have white space in the background. That's the ground substance. It's liquid, no fibers in blood. The cells that are dark pink on the outside and lighter on the inside, that's your red blood cells, your erythrocytes. These darker odd-shaped cells, that's your leukocytes, your white blood cells. And then the little dots here, and there's one there, that's your platelets. For each of your connective tissues, make sure that you can identify the tissue by looking at the picture or the microscopic image. Make sure you can identify any specific fibers or cell types within the ground substance. Identify a location for each connective tissue and know a function for that connective tissue.